Okay, so today we are going to be combining those things that we did through the week. So we are going to be doing centripetal plus gravity. I know you're excited. So, centripetal and gravity. Now, maybe let's talk. Here's Earth. Here's the moon. The moon goes like this around the Earth. Ta-da! Now, maybe you can see something here. This is a circle. It's not really a circle, but it's close to a circle. So close that we are going to pretend that it really is a circle. Okay? Now, since this is circular motion, that means that there is centripetal force. What kind of centripetal force is there? There's gravity, the force of gravity. I'm going to use a big G because it's the grown-up version. So, what do we do now? Well, we know that the force of gravity is going to equal I'm going to put it on this side, the force of centripetal, because it's more of what I'm used to and I think it'll help you more. Now, force of centripetal is going to equal mv squared over r, right? And force of gravity, like we did yesterday, is g big M little m over r squared, right? So far so good, hopefully. Now something you should notice here is that a lot of things cancel out. So the masses here cancel out. Now this is the little thing mass, this is the big thing mass, the thing in the middle. Also, the radius cancels out almost all the way. It just cancels out the squared. So we get a v squared is equal to g m over r. Ta-da! So the mass of the orbiting thing doesn't matter, but the mass of the orbited thing does matter. So this is the sun, right? For example, which is a bad example because I just drew a picture of the Earth. But whatever. The mass of the thing moving doesn't matter at all here. So this is a formula we are going to use a lot. I never bother memorizing this formula because I just do this. And it's so much, you should know both of those pieces and then just know to put them together. All right, let's do a practice. The moon is that far away from the Earth. I know it's not a real scientific notation, but I didn't want to bother converting it from the chart. Away from the Earth, how fast does it travel? And that's the mass of the Earth. I used a big M because it's the Earth. Alright, so we're going to do this kind of thing here. I don't even remember the formula from just a little while ago. So I'm going to write mv squared over r is going to equal g big M little m over r squared. Cross out, cross out, cross out, cross out. Hey, that makes sense. So v squared is going to equal g, which is 6.67 times 10 to the negative 11. Times big M, which is 5.97 times 10 to the 24. And this one is 0.384 times 10 to the 9 squared. No squared, sorry. Because squared is gone now. Ta-da! Alright, now it's typing time. So 6.67 times 10 to the negative 11 times 5.97 times 10 to the 24 divided by 0.384 times 10 to the 9. So typity, oh, it's a big number. Oh wait, well, the square root it first, to the square root. Alright, so V, I got a 1018 meters per second. That seems reasonable for outer space stuff. Outer space stuff travels fast. What about air resistance? Get it? Anyways, so that is what the speed of the moon is. It moves fast because it has a long way to go around the Earth. Alright, let's do another one. See if you can pause the video to figure that out. Alright. Cool. How fast you need to throw a football in order for it to return to you, like around the Earth. So, you're throwing your football because you're socially distancing from everyone, so you have to play catch with yourself. Okay. So v squared is equal to g big M over r. I remembered it after writing it enough, I guess. So g is 6.67 times 10 to the negative 11. M, the mass of the Earth, is 5.97 times 10 to the 24 still. And we're going to be dividing by the radius of the Earth, because you're right about at the surface here. Now, if you add 2 to this number, it's not going to change anything. 6.38 times 10 to the 6, no squared. Alright, let's solve this here. 6.38 times 10 to the 6. I just used the old entries because we're still on Earth. To the square root. So you are going to have to throw the football at 7,900 meters per second, thereabouts, which is very fun, isn't it? Alright, so far so good. Hopefully you figured that out. You should notice that it is faster. The lower down you are, the faster you will have to go because gravity gets stronger and stronger, so you have to go faster to kind of cancel it out. Alright? That's how it works. Or you could just think mathematically because the r is in the denominator. Anyways, let's talk about period. You know, something like that. If Venus is 108.2 times 10 to the 9 from the Sun, how many days does it take to go around? The mass of the Sun is still 2 times 10 to the 30. Okay, so here's the dealio. Here's what we're going to do. I'm going to do this with algebra letters, just so we can see the process better. So we remember how v squared is equal to g big M over r. Now, velocity, in case you forgot, is going to be distance over time. So I am going to replace this with a d over t squared. Well, and the squared stays too. So far, so good. Now, what we also know is something about the d. The distance is going to equal the circumference. So this is going to be 2. I'm going to distribute the squareds. 2 times pi times r. Right? Are we okay with that? Hopefully. Because your Venus goes in a circle. How far does it go? It goes 2 pi r. Now we're going to divide by t squared. Now I put a capital T for this one because that's the letter we use for period. Alright? So for orbiting. Little t is for any group of time, but big T is used for like one cycle. Alright, that's what that is. And this is still going to equal g big M over r. Alright, now you couldn't kick the r over and make r cubed or whatever. But anyways, we're going to solve for big T. So I'm going to just do big T squared. So kick this over, kick those over here. That's going to equal 4 pi squared r3 over gm. Alright, so far so good. And that's basically all you're going to do. Now, I wouldn't bother memorizing this formula either, because just reinvent it like I just showed you. I don't memorize these fancy formulas. I memorize the important ones, because who likes memorizing? Anyways, so t squared is going to equal 4 pi squared r to the 3, and r is 108.2 times 10 to the 9 cubed, divided by 6.67 times 10 to the negative 11 times 2 times 10 to the 30. Alright, so we got to type this whole thing in and square root it. So 4 pi squared, not often you do a pi squared, times 108.2 times 10 to the 9 to the 3 divided by 6.67 times 10 to the negative 11 divided by 2 times 10 to the 30. And you're going to get a big number, a 3.7 times 10 to the 14. Now, this is a big number because this is in seconds. Let's divide by some stuff. Let's divide by 60. Now we're in minutes. Divide by 60. Now we're in hours. Divide by 24. Now we're in days. Oh, I forgot to square root it. Oh, pooey. Alright. Well, here I can fix that, I guess, real quick. T squared is equal to. T is equal to. Oh, another big number. 1936167 whatever. Divide by 60, divide by 60, divide by 24. You get 224. 224 days. Earth days, I guess. And that makes sense. It should be less than 360, right? Because it's closer. Cool beans. Alright, let's do one more. Alright, here's for you. A satellite in geosynchronous orbit goes around once a day. What is the radius you have to have for the satellite? Here's the mass of Earth. So what's the altitude? Well, what's the radius from the center of the planet? Who cares about altitude? Okay, pause the video, give it a shot, and then I'll do it too. Okay, hopefully you're done by now. So v squared is equal to gm over r. Now, I'm going to forget this formula by the end of the day, so don't feel like I'm always going to do it. You know, I'm going to start over from the universal law once we get there. So v squared is going to equal 4 pi squared r squared over t squared is equal to gm over r. So I'm solving for radius. I'm just going to solve for radius real quick. R to the 3 is going to equal gmt squared over 4 pi squared, right? Yeah, that's everything. So g is 6.67 times 10 to the negative 11, because it rhymes, it's easy to remember, times the mass, which is your 5.97 times 10 to the 24, times t, what's the period? So 1 day is equal to 24 hours, which is equal to 24 times 60 is going to be 86,400 squared divided by 4 pi squared. Okay, typing the whole thing in now. 6.67 times 10 to the negative 11. Ooh, times 5.97 times 10 to the 24 times 86,400 squared divided by 4 divided by pi squared is equal to this number, which is a big number, but it's cubed, so you got to do to the cube root. So your radius, r, is going to equal 4.22 whatever times 10 to the 7 meters. Ta-da! Hey, so that's that. Hopefully that helps. Well, it's always fun to put these together. Like and subscribe for more videos. We'll see you later.